You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Impossible space drives. Stop! Don't adjust your podcast player. If the topic of space drives sounds impenetrably geeky and techy and uninteresting to you, then I encourage you to give me the benefit of the doubt here. It is actually not all that complicated, and it's a prime example of a specific brand of conspiracy mongering that we see all the time. We've grown accustomed to hearing that the government suppresses all kinds of miraculous technologies to protect corporate profits, and the subject of reactionless space drives has all the marks of being yet another iteration of this same belief. Whereas some fringe inventors continue toiling at perpetual motion machines in the belief that free, limitless energy is possible, others theorize about technologies that could eliminate the major problem of space travel, all in the belief that the government knows such things are possible, but covers them up. Today, we're going to look at a number of these proposals and see why they would or wouldn't work. Simply stated, that major problem is that flying around in space requires reaction mass. If I want to change the direction of my spacecraft's movement, the only physically possible way to do that is to expel a certain amount of mass in the opposite direction. It can be a lot of mass that I push off from gently, or it can be a little mass that I push off from aggressively. However it's done, I need the inertia in that reaction mass to push off from. Why is this the only physically possible way of changing movement? Well, because of a little thing called Newton's third law of motion. For every action, there is an equal and opposite reaction. Although we refer to this as Newton's third law, it's important to remember that he was just the guy who formalized and proved these laws. I often hear advocates of alternative sciences say things like, well, who says Isaac Newton had all the answers? Since when does he know everything? Well, we mustn't conflate the laws with the man. These are the most thoroughly proven physical laws we know of. The math adds up every time. There is no hypothetical in all of physics or in all the observations in nature in which an action can be shown to lack an equal and opposite reaction. It is an absolute physical law of nature. We can wax philosophical and say there are no absolutes, but when it comes to math and physics, there are. In short, to those who question the inviolability of these laws, having a YouTube account does not give you power over the physics of the universe. If I want to travel to a distant star system, I need a huge amount of acceleration in order to overcome the enormous distance. Immediately, the problem becomes clear. If I plan to expel that much reaction mass, I have to start my journey with an impossibly gigantic cargo of reaction mass, which has so much inertia that I'd never get started. The idea of space travel depicted in science fiction requires a space drive, our name for a hypothetical, reactionless drive system. Wouldn't it be spiffy if we could zip around space without the need to carry or constantly expel any reaction mass? Of course it would. So the result is that we see something found in nearly every walk of life, eager people searching for magically easy solutions to difficult problems, usually without understanding the depth of those problems. Thus, today we are awash in proposals, patents, and prototypes for reactionless space drives, not a single one of which, according to the laws of nature, can ever work. For the purpose of this discussion, we should clarify that there are methods of changing the movement of the spacecraft that depend on external forces. And so, strictly speaking, they are also reactionless drive methods, though clearly unrelated to the motors that are the subject of this episode. These include the solar sail, which uses pressure from solar radiation against a literal sail, the closely related beam-powered propulsion, which substitutes a ground-based laser, microwave, or particle beam to push the sail, and the gravitational slingshot, in which a spacecraft's vector is carefully aimed past a high-mass celestial object such that it can acquire kinetic energy by swinging around the object. Reactionless? Yes, but of limited practicality and not at all similar to the space drives of today's discussion. So now let's have a look at a few of the most popular claimed space drive designs. There are certainly many others, but there are only so many we can look at in the space of a Skeptoid episode. Let's begin with the EM drive. This one perennially gains headlines because someone seems always able to persuade researchers at NASA or various universities to verify experimental results that appear to show success. The EM drive is the most famous example of a broader category called an RF resonant cavity thruster. All depend on the principle of microwaves, or other radio waves, bouncing around inside a closed chamber, which is shaped in such a way that the pressure of the bouncing waves will be greater on one interior surface than on the opposite one, thus pushing the whole system. The EM drive was invented in 2001 by Robert Scheuer, and various iterations have been tested over the years with a few reports of positive thrust. Uselessly infinitesimal amounts, but still positive. These have been followed up with replication attempts. So far, they always fail, and a variety of measurement and experimental errors always crop up to explain the positive result. These have included thermal heating, electromagnetic interference, and others. Headlines you see, and will probably continue to see, extolling the EM drive as some kind of successful new breakthrough, really just refer to these unsuccessful replication efforts. A common analogy explaining why the EM drive can't work is that of sitting inside a car and trying to make it go by pushing on the windshield. There is no physical way for the waves inside the chamber to push against one wall without an equal and opposite reaction against the other surfaces. The gyroscopic inertial thruster. This one is based on forces familiar to all of us. Swing a weight around on a string, and you'll feel that weight's centrifugal force try to pull you toward it. More and more force the faster you swing it. The idea here is that you'd swing it faster when it's in the direction you wish to travel, and slower when it's behind you. Why wouldn't this work? Simple. Any changes to the force you'd need to speed it up or slow it down would be equal and opposite reactions. The net can only ever be zero. There are many designs of gyroscopic inertial thrusters, but all are governed by the same fundamental law, no matter how elaborate or creative. This is similar to the trick you can perform in some museums where you sit on a rotating stool holding a spinning bicycle wheel. By tilting the wheel, you can make your stool spin around. This is because of conservation of angular momentum. You and the bicycle wheel comprise a system with constant angular momentum. If you were doing this in space, you could tumble all kinds of directions, but you'd never move anywhere. As much as you have angular momentum, you and the wheel also have inertia, and one has no impact on the other. The Dean drive. This contraption, invented by Norman Dean in the 1950s, was probably an example of this last type of device, though we don't know for sure because he was secretive and never let anyone examine it or test it. It would gradually scoot across a table when activated, though observers concluded any movement was just the result of friction and the device's vibrations. One red flag is that Dean openly claimed not to have violated the third law, but to have established a new fourth one, sort of a word salad based upon something he termed gravitational inertial radiation. As Dean's device was promoted mainly by the editor of a prominent science fiction magazine, a trend among science fiction fans has become to refer to all reactionless space drive concepts as Dean drives. So Dean's concept at least has that going for it. The Alcubierre drive. This one is almost literally the Star Trek warp drive. Mexican physicist Miguel Alcubierre Moya wrote a 1994 paper called The Warp Drive, Hyperfast Travel Within General Relativity, and emailed actor William Shatner that his idea was directly inspired by Star Trek. However, he based it on sound physics and kept it consistent with Einstein's field equations. At least that's the way it's typically explained. Like the famous drive in Star Trek, Alcubierre's worked by surfing a sort of virtual wave of space-time, by constantly shrinking the space in front of it and expanding the space behind it. But to do this, it would require a region with negative energy density, meaning lower density than an absolute vacuum. a concept that works only if one has something called exotic matter. Exotic matter is a placeholder term for any hypothetical matter with properties that deviate from the known types of matter. So the stuff needed to make the idea work is only hypothetical, and even if it was real and obtainable, it would be needed at staggering energy levels. So while it's not accurate to say the Alcubierre drive is pure fiction, it's also not accurate to say that it's possible. The default feedback I would normally get to an episode like this one is the straw man charge, "You're saying we shouldn't test these ideas or look for new ones," which is, of course, silly. Once when an EM drive test was in the news, a former program manager at DARPA told Popular Mechanics magazine, "Given the number and diversity of claims about EM drives and other exotic physics, my opinion then and now is that DARPA should invest modest sums to experimentally assess such claims, albeit only where credible experimental evidence exists." Accents on the modest sums and on the only where credible experimental evidence exists. And I think that's a pretty good allocation of attention and resources to something so spectral as a space drive. Evidence lacking, any claims about having beaten the laws of physics can probably be safely ignored. But if someone does find something that's measurable, then it's certainly worth taking a look. It's not likely we'll find the laws of nature have been broken, but it's plausible that some interesting side effect, not previously predicted, might have been discovered. Nevertheless, you can probably rest safely in your skepticism of the next big headline trumpeting a breakthrough in reactionless space drives. It's a cliché, but it's nearly always proven true whenever people claim to have surmounted the laws of nature and come up with some miracle contraption. If it sounds too good to be true, it probably is. But some people are every bit as good as they seem. Skeptoid's premium members, like Brienne, Nancy Alexi, Rick Hodge, and Noah Fehrenbacher. Thanks so much for making Skeptoid possible and being my partners in sharing the tools of critical thinking. But one quick question for all of you listening. What are you wearing? Is it a Skeptoid shirt? No? Well, why not? Come to the Skeptoid store and take a look at these Skeptoid logo shirts and more. We've got all the styles, sizes, and colors. Skeptoid.com/store. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.